Hello and welcome to Robotic Process Automation with SX. My name is Peter McGeever and I will be taking you through this demonstration. If you have any questions, please send them to the contact details I will show at the end of the video. I'm going to start by introducing you to the concept of the NDL digital toolbox. Digital transformation comes in many different forms and different directions, and the important thing is trying to keep control of this and trying to keep your destiny in your hands. At NDL, what we can do to help is create tools to enable you to create the vision and drive of your digital transformation. We produce a toolbox full of tools which are functional, comprehensive and easy to use. That is our drive and what we aim for. In this demonstration, we are looking at SX, our robotic process automation platform. So let's look at what Robotic Process Automation, or RPA, is. SX in the past has primarily been used as an API replacement, but it has more capability than that. Here are some examples. Process automation, rekeying, doing repetitive tasks that are so boring and laborious to do, but that need to be completed reliably. Robots excel at these types of tasks. Data integration. This is where you could use APIs, but what happens when those APIs are not available? What happens if those APIs are available but don't allow you to do everything that you need them to do? Automation can fill this gap by extending or replacing APIs. Synchronization. You might have multiple systems that need the same data in them. What happens when one system is updated? How do you synchronize that data across all other systems? Robotic Process Automation will help you do that. Migration. We see a lot of this. People moving from one back office system to another, and the questions about how do we get our existing data out of our old system and into the next. Robotic Process Automation can help you achieve that. Extraction. This is where you might want to give people access to some information, but you don't want to give them access to everything. You can use Robotic Process Automation to extract just the information that's needed, and it could be repurposed, reformatted or put in an app or shown in the browser. All these are really good examples of where Robotic Process Automation can help you, and indeed are all examples of how our current customers are using our product. So what are the benefits of Robotic Process Automation with NDL? Firstly, it's about scalability. We all want to increase the work we are doing, the number of transactions an organisation can put through, whilst in a position where it's not possible to increase your workforce, or you're in a position where your workforce is decreasing. Automation can help you do that. Quality. If you train your bot correctly, the reality is that it will deliver quality transactions consistently. I think we can all admit as humans we can't do that, but bots could. Agility. It gives you the ability to develop those new concepts, those new ideas, and to do it quickly in an agile way because you won't have to be changing the core systems. You'll be able to do this in a few weeks or a matter of months rather than many months or even years. It's safe. We're using existing business logic provided by the application vendor, ensuring data integrity. It's universal and will work with any application, whether it be web-based, Java or .NET. If it can be presented on a Windows screen, then the application can be driven by a robotic software. And finally, it's cost effective. It's a toolkit, so you buy it once, you're in control, and you can use it wherever in the organisation you need to automate processes. Unlimited automations, unlimited processes, one fixed price, expanding your digital workforce. The scenario we'll be looking at in this demo is automating access to a legacy system through a web form. Our legacy system is a housing back office system. It's rather old. You can search and display property details, and it was written in Visual Basic, but it could alternatively be a Java application or HTML, for example. What we're going to do is introduce a self-service web form, which will allow the user to check the customer reference number by looking up the name and address. On our web page, we will type in the customer reference and then retrieve the name and address details. So let's see this in action. On the demo machine, we have our e-form for Orange Grove Housing to report a repair via their web portal. What we're going to do is search for a tenant by their tenant number. To do this manually in the application, we enter the tenant number into the tenant number field and click the Find button, and this returns the tenant name and address. Let's move to triggering the process from the eForm. Again, I start by entering the tenant number into the eForm and clicking Check. This then triggers our robot to follow the same actions as I did manually. The robot script then returns the name and address details to the eForm. So how do we do that? We saw the form comprising of fields and buttons, and on the other side we saw the web form that we were implementing. This is just a standard web form and is not part of the product. This just represents any type of eForm that a vendor may provide or one that you might write yourself. In the middle of all of this we have the SX server. This would normally be running in a virtualized machine on your data center and is controlling a number of virtual PCs which will act as our robotic users driving the back office application. Each bot will be able to run the housing application. And what's driving all of this is a script which we will write, and this is then exposed as a web service. The eForm calls the web service, SX activates the appropriate script, which in turn conducts the search on one of the bots before passing the details back to the form. So how do we produce that script? We provide two tools that allow us to do that. We have the SX Profile Editor, which we will use to discover the capabilities of our back office systems, what buttons there are, what fields there are, and what we can do with these controls, as well as other things about the application. We use the Profile Editor to build a library of profiles representing each screen in the application. This is a one-off process, and when we've finished building our library, we move on to the SX Workbench. The Workbench provides all the functionality required to build our script. Some customers prefer to work within Visual Studio, which you can do by simply importing the controls that we provide into your Visual Studio environment, but we'll put that to one side. The final component is the SX Console. We will use this later to configure and manage the operation of our SX server. Let's look at the stages involved in building the automation. The first thing that we must do is profile the application. Then we will build our script, and then we'll need to set up our bots, the virtual machines that will drive our application. We will need to configure our web service, and then finally run the process. Let's start our tour with a look at Profile Editor. The purpose of this program is to discover the capabilities of our application. Listed here are the main types of environments that we work with: .NET and pre.NET, Java, HTML, WPF, and even green screen. Simply put, if you can run it on the Windows device, we should be able to automate it. What we're creating here is a profile library. At this stage, we don't need any programming skills. So let's take a look at Profile Editor and see how we set about profiling an application. So back on our demo machine here, we will look at profiling the Orange Grove application. The first thing I'm going to do is create a new application. I'll give that a name, Orange Grove Demo 2, and click on OK. This then asks me to identify the target application. In this demo, I'm just going to identify the application and not bother with the application bindings. So I'll deselect Create New Instance and click on OK. It moves to a window identification wizard. I click Start, select the Orange Grove Housing application window, and then confirm the details are correct and click OK. That creates a new profile container under our application tree for this particular window. What we're trying to do is create a map of the application that's then used in our scripts to access all of the controls. The first thing we need to do is identify the tenant number field. So I'll right click on here and select New Named Control. As I move my cursor over the field, it highlights it. I can click on it and it shows the name that comes from the control details. This is fine, so I'll just confirm that. We can also access the Locate tool from the Profile Editor application ribbon, and we will identify the Find button and again OK the default name. As a final alternative, we can find a control on the Child Control Tree panel. I will cut locate name and again OK the default name, and the same for address 1. For the purposes of the demo, this is all I need to profile, so I shall leave it there. Whilst we're in Profile Editor, there are some other features worth talking about. First off, we shall have a look at the Windows identification. Let's start by opening another window from Orange Grove Housing. I'll do this by causing an error that will show a pop-up box. I can do this by entering an invalid tenant number. When the pop-up appears, Profile Editor creates a new empty profile container for the new window. It has the name Error, which is the title of the window. This has a label in it that reports a specific error message. From the control tree, I shall verify the label text, and this confirms the value provided by the accessibility name. I want to use that as the control value, and it will ask if I want to add this as a named control. It's provided a default name for this control, but I'm going to change it to something that's easier to reference in my scripts. Once we have this, we can use it in our window identification rules. I can use the control as part of the identification process of this window. I'm going to set it to read the value and check if it contains the word system error. This means that I can verify the error box uniquely. If I have another window with the title error, it will be treated as a new window if the label doesn't contain system error. I can demonstrate this by opening another error box by using a different invalid tenant ID. This gives a message of unknown error, so it doesn't match the rules for the error box that we had before, so Profile Editor creates a new container for that. This function is quite useful for identifying things like tab controls or where different screens show the same window title. Other options available to us are being able to create regions. We can use regions to interact with controls that aren't appearing on the control tree as they haven't been exposed by the application, but we can also use them to return an image from the screen and save the image to the file system or to a database. We can also use named regions to perform optical character recognition on text. Moving down the panels, we can see mouse macros, where we can record mouse movement and clicks to automate a drag and drop action, for example. Finally, we have keyboard macros to specific keyboard actions. There are some stock macros, but there are much better ways of completing these actions within the SX code. So the keyboard macros should be considered as a legacy method. So I'll save this profile off and I'll be using it as part of my demo. So at this stage I haven't needed any programming skills, they're not required. The interface is pretty much point and click to create a map of the target application. It's quick and easy to use, but it is powerful. The Profile Editor can map a wide range of target application types from Java to WPF or WinForms to Silverlight. So that was the Profile Editor and its key features. With the application loaded, you could see how we profiled a single screen, adding in controls that we need for our automation. This process will be repeated for each screen in the application, and each profile is saved to the profile library. Looking back at our life cycle, the next stage is to build a script, and for this we will use the SX Workbench. The Workbench uses drag and drop technology to build scripts, though some coding skills will be required in a language such as Visual Basic. The Workbench has a similar look and feel to Visual Studio, and third-party tools such as Visual Studio can be used to develop solutions in .NET as an alternative. The Workbench has numerous code options, but today's demonstration will be using ASP. In a moment, we'll look at the Workbench and we'll see how to generate code for our automation. So here's that SX Workbench. Workbench is basically where we write our scripts, etc. The layout of the Workbench should be familiar to anyone that's used a Microsoft Office application. It has several panels which can be docked and undocked from the main window and moved around to suit your preferred layout. So looking at the panels, first we have the workspace panel, where we can find all of our script pages as we open them. Below that, there is the AWI Functions panel, where we can find a list of all the methods and functions available for AWI-SX. Across the bottom is the Find Results panel, and on the right, the Application Profiles panel that shows all of the application profiles available, including the one that I created in the last demo section. We're just going to create a new file here and make a start on our script. I'm going to write my script as an ASP page. This is basically a web page, so it will run on a web server. Let's start by showing you some of the drag and drop options. I can basically drag and drop functions into my code page, and that opens up the function wizard, and I can add parameters needed for the function, and that will generate code in the code window. I can also do the same thing from the profile panel, dragging in tenant number fields, and that writes the default code for the control type. In this case, it's reading the value and returning it to a variable. I'll just delete this and let's get on with the code I need for the demo. I shall be using some prefabs whilst I create the script, and this will make writing the script a lot quicker for the purposes of the demo. SX comes with some pre-installed prefabs to cover the most common code snippets that you will need to get started. There are various prefabs for the different types of scripts that you might want to write, like ASP, VBS, ASPX, etc. To create a new ASP script, I will use the new ASP prefab. This asks a few questions for parameters required for my script. Firstly, the team of bots to use, which I'll come back to later. The application name of the profile collection, and then the profile that we're going to start with, Orange Grove Housing. I click on OK, and this will generate the beginning of our script. This generated code, if I was to run it now, would connect to the Orange Grove Housing application and finish. So I'm going to move down to AWI code here, and I'm going to add some actions. To start with, I'll use another prefab, readRef from post. This code will read data from the eForm and writes it to a variable. Next, we need to write the tenant number in Orange Grove application. I'll use the setNameValue method for this, and I can simply drag and drop it into the code window. I tell it which control I want to write the information to, and I'm going to pass the value as a variable. We use the variable from my script, which is strref, which will contain the tenant number. Now, if you remember from the first demo, we need to press the Find button. I can quickly add this by dragging button Find from my profile and click OK and add that to my code. Next, we'll need the name and address values from Orange Grove Housing back to my script. The default action is to get named value for edit controls, so I can just drag and drop the controls into the code panel. The wizard opens and we can see it says get named value. I'm going to just change the string name so that it's, that's returned so that I can identify them easily in my code. So str name for the name. For the edit address one, it will let me select get contents from the context menu if I right click. I'll set the return value of this one to str address. Now I just add the return name and address prefab. This will send the response back to the web page that our eForm will read with the name and address in it. So that's the script done. I just need to save this to my web server root folder so that it will run on my web server. I'll save this as orangedemo.asp and I'll save it in my www root folder. I will be using this script in my demo later, so we'll see what it does then. Okay, so we've looked around the workbench and looked at its key features. We used a profile library to build our automation. We saw how to start writing the script in ASP and make use of some reusable code known as prefabs for rapid development. The automation was written so it would load the back office application, input the reference number, press find, retrieve the address details and display them back in the web form. So that is the development complete. We've profiled and then written the script. Now we need to configure our environment so that we can run the script. Looking at the diagram from earlier, you can see on the right our army of robots, which are used to run our automations. 3 of the robots have Orange Grove application installed on them. We need a way of telling the SX server which of these robots can run the application when the automation is triggered. To do this, we place the robots in a team of robots. Our script can then query the team of bots for the first available machine on which to run our automation. In this next demonstration, I will show you how we can use the SX console to set up the team of bots. So here we have the SX console. As you can see, we have the local server set up on here, and we can see our team of bots named Demo. Within those teams, there are details for individual bots or virtual machines that will run the robotic actions. These can be identified by either their IP address or by using their allocated network names. And if required, we can mark them as in use. At the bottom we have the Audit tab where the clients log actions and communications, and we can use this if we're diagnosing an issue with the script, for example. So for the demo, I entered the team of bots as demo when I used the new ASP prefab. The next stage is to set up the AWI transaction configurations. This is our web service. In the web service, here is our orange cust lookup transaction. This is the transaction that's called from our eForm. I'm just going to edit the URL to point at the script that I've written. I'll click on Update and we're ready to go. When the script runs, if you watch the bot, you should be able to see it go into use. I'm just going to change in the eForm the tenant number and I'll click Check. In the console, you'll see the bot becomes busy. The robot does its actions and the result, Jane Marple, is returned to the eForm. So this has run my script through and has shown how the robot runs through its actions and the information is returned. As we've seen in the demo, the SX console is provided with SX as a management tool. It's where we can manage our bots into teams, and they can be ordered so that the higher specification machines can take priority and be the first to be used. It can also manage a whole farm of SX servers and provides full access to the audit information that the system is collecting as the automations run. So back on our development life cycle, and that's the end of the cycle. What we've just seen is a direct automation. We had a web form, which could be any eForm system, generating requests through a web service, calling the automation before sending the information back. By using web services, we could extend the use of our automation to other areas, such as calling it from a CRM system or from our mobile product, MX. Many of the processes that we come across do not require real-time access. Bulk updates, for example, don't need to be done in real time. As part of the SX products set, we provide an additional utility called QX, which allows us to queue transactions and process them in a managed way. The benefits of this are that we can take out the peaks in our workload and make better use of our resources. It can also time shift transactions. Things that don't need to run during the day when our systems are busy and the licenses are in use can be run overnight when things are much quieter. Let's take a look at the QX architecture. QX can call the SX web service in the same way we've seen already. It can pull its transactions from a number of places, such as folders or SQL tables, for example. It will monitor these locations for new transactions to appear, which it can then pull in and process directly. Or you can use the API provided with QX to programmatically process transactions through it. All transactions can be queued in QX until the robot becomes available. QX comes with a console to configure and manage the queues and prioritise transactions and access auditing details. So back on our demo machine here we have the QX console. We have a few queues. At the moment the only one we're interested in is the log repair queue. We can see here I have 3 items in the queue already, but the AWI side of the QX queue is currently disabled, so they won't process for the moment. What I will just demonstrate here is I shall fill out the details on the e-form and add a new repair, and we'll see the details added to QX as it's monitoring the database that the information is added to from the e-form. QX will detect this as a new record and add it to the queue, showing as a new item in the log repair queue. And here it is. And I'm just going to switch the AWI settings to enabled, and the queue will try and process the items one by one through the back office system. The data is passed to the script, which enters the tenant number. It clicks find, returns the name and address, then clicks repair and adds the details before telling QX that it's been successful and moving on to the next item in the queue. And then again it searches for the tenant, adds the repair, etc. Then finally we'll move to the one that we've just added. Once this is completed, the queue will then continue to monitor for new items and process them as they turn up. So in that demo we saw the key features of QX. We had a queue linked to a database table which monitored for new transactions to process. Any new transactions were pulled into the queue. When the queue was activated, you saw the transactions being processed one by one through the orange housing system. The principles of this relatively simple example that you've seen today can be extended and applied to many types of scenarios. We have many public sector and commercial customers that rely on SX to do this type of transaction day in, day out, 24 hours a day. The process that you've seen in this demonstration uses SX to perform an unattended automation. But we do also have a desktop version of the product called DX, which can perform attended RPA processes. DX is installed onto each user's desktop and drives the automation process locally on the machine in front of the user. DX automations are developed in the same way by using the Profile Editor and Workbench. Both tools are universally applicable, supporting environments such as Java, .NET, HTML, WPF and so on. There has been nothing that our clients have asked us to integrate with that hasn't been possible to do, and we always welcome the challenge. We've seen how we can drive automations through a web service, but there are other ways of using it. Some clients are monitoring a folder for XML documents, or spreadsheets, or even emails, using that as a trigger to run a process, entering data into the back office system, removing the need for manual duplication of data, cutting out the boredom and making things much more secure. So finally, automation and integration does come up time and time again as a big issue for everyone. From what I've shown you, it is possible and we can make it simple. From the work our customers have done over the years, it's also very reliable. Building on that, today, NDL bots will probably process in excess of 1 million transactions in a wide variety of settings, from councils to construction, from banking to the NHS. NDL bots are making a huge contribution to the services these organisations deliver. The benefits can be huge: faster processing, more reliability, better accuracy and safer transactions, but overall a more efficient solution. And that's the end of the demonstration. Thank you for your time. If you have any questions, please feel free to email them to info@ndl.co.uk. You could also call us on 01937 543 500 or tweet us at NDL Software Ltd.